In this module, we're going to talk about how to draw Lewis structures. And this is broken up into two parts. This is the basics of it. You probably have seen this stuff already. So anyway, what is a Lewis structure? Well, it gives you some information about the molecule that you don't get from just looking at the formula. For example, this molecule right here. It tells you, there's 2 carbon atoms, 3 hydrogens, so on and so forth. But the Lewis structure looks like this. It tells you that there's a carbon atom that has single bonds to a fluorine and 2 hydrogens and another carbon, which has a double bond to an oxygen, and so on, like that. It gives you more information. So, to draw a Lewis structure, there's several steps. The first step is this. You look at the formula. So you'll be given the formula for the molecule, and you're asked to draw the Lewis structure. So you count up the number of valence electrons in that molecule. So sulfur, if you look at the periodic table, you can tell it has 6 valence electrons. It's right beneath oxygen, and each oxygen has 6 valence electrons. Now, if there's a charge on the compound that you're drawing the Lewis structure for, if it's a negative charge, for every negative charge, add 1 electron, valence electron. If it's a positive charge, for every positive charge, subtract 1 valence electron. So we'll use sulfate as our example. There's 6 valence electrons in sulfur times 1 sulfur atom, plus there are 6 valence electrons in oxygen times 4 oxygens, plus 2 more from the negative 2 charge, which adds up to 32 valence electrons. Next, arrange the atoms. A few tips, I guess. The least electronegative element will almost always be in the middle. Sulfur is less electronegative than oxygen, so we put sulfur in the middle. Hydrogen can never be in the middle because it can only form 1 bond. It only has 1 electron, can only make 1 bond. And oxyacids or oxo acids, like sulfuric acid, for example, nitric acid, and so on, the acidic proton is going to be attached to an oxygen atom. For example, this is sulfate, but if we were doing sulfuric acid, which is H2SO4, just to show you real quickly, we would put those 2 hydrogens outside of any 2 oxygens, doesn't matter which 2, something like that, when we're arranging them. But that's not what we're doing now, so we'll leave them off. And we still have 32 valence electrons. The next step, after you've arranged all the elements, is to attach the outer atoms to the central atom with single bonds, just to make a single line. And every time you make a line, subtract 2 valence electrons from your total that you started with. So we started with 32. There are 4 lines, times 2 is 8 valence electrons that we've used up to make those bonds. And we have now at this point 24 electrons left, valence electrons. Next. Satisfy the octet rule for the outer atoms by adding lone pairs of electrons. The one way of interpreting the octet rule is that an atom tends to gain or lose electrons so as to have the same number of electrons or valence electrons as the nearest noble gas. Well, the nearest noble gas to oxygen is neon, which has 8 valence electrons. So oxygen's trying to get 8 valence electrons. Now back here, in this structure, oxygen only sees 2 valence electrons. Remember, each line represents 2 electrons. And those 2 electrons are seen, they help satisfy the octet rule for both the oxygen atom on one end and the sulfur on the other. So before we added these lone pairs, each 2 dots is one lone pair of electrons. Oxygen only saw 2. It needed 6 more, so I put 6 dots. And when you're putting them, put them in pairs. Think about a box around the outside of the oxygen, 2 dots on each side at most. So I've used up now 6, 12, 18, 24 more of our valence electrons. Now all of our valence electrons have been used up. And that's one of our goals in drawing the Lewis structures. We have to use all of the valence electrons, but we can't add any extras just making them up. So at this point, we have the octet rule satisfied for all the oxygens, and sulfur also has its octet rule satisfied. It sees 2, 4, 6, 8 valence electrons. Sometimes when you're drawing a structure, you'll find that you've run out of electrons by satisfying the octet rule for the outer atoms, but the central atom still is missing electrons. That's not the case here. What you do in that case is you make a double or a triple bond so as to satisfy the octet rule for the central atom. And when you make a double or triple bond, what you do is you take two dots, one lone pair from one atom, and you erase them and you make them into another line, making that a double bond. Another one if you need a triple bond. Now, if there's a charge on the molecule, like there is on sulfate, what you do is you put brackets around the outside of it and put the charge in the upper right-hand corner. All right, so that's the basics on how to draw a Lewis structure. In the next module, Lewis Structures Part 2, we're going to take it a little bit farther.